Now, last day we have learned that how the position of any place or any locality or any landmark can be shown by a vector. Here, from your school gate, we'll draw a vector of the playground which is in east direction and at a distance of 105 meter from your school gate. Here is position vector of a Taylor give and take Taylor, which is exactly in northeast direction of your school gate and at a distance of 120 meter. And Dugda hospital we located, which is in the direction of north and which is at a distance of something like 90 meter or nearly equal to 90 meter. All these things, all these positions are shown by a vectors. Three locations, three different vectors. Their length is represented by the line segment and arrow is representing at what direction they are located. We will learn these things in a little bit different way today. In last video, we also learned about the unit vector. This is a vector, suppose this is a vector AB. And unit vector, this is representing suppose 5 meter. This is representing 5 meter in the direction of, this is a displacement and this is in the direction something like if this is east, this is north, this is south, something in east-south direction, southeast direction. And if you want to find unit vector along this direction AB, so we have to unit vector along AB. Unit vector is represented by a cap. This is called cap. This is going to be vector AB and divided by 5. When the magnitude is divided, when a vector is divided by its magnitude, it turns unit vector in the direction of the given vector. That we learned. Clear? Now, if we plot these vectors in a graph paper or in an analytical plane, this is called analytical plane, unit vector along the direction of x is I, positive x direction. It is by default. We call any vector which is in the direction of x, and if that vector is divided by its magnitude, then it becomes the unit vector, and that unit vector is I. So for time being, you must remember that unit vector by default in the direction of positive x is I. Unit vector by default in this direction is minus I. Unit vector in the positive y direction is j, j cap. And unit vector in the negative y direction, it is minus j cap. And using this unit vector, which is by default, we can represent any vector. We will start with position vector of some location, then we will also move further for other vectors also. Okay, so suppose what we learned in part 1 of position vector, that I am telling you, okay, how they can be represented in this analytical plane. So be serious. Now you can see that from your school gate, the football ground is in the east direction, and your tailor, give and take tailor, is in northeast direction, and your hospital is in north direction. And I am going to plot all these 3 points in a craft paper. So in this coordinate plane, if this is your school gate, let's take it origin, and this point, this coordinate, which is at a distance of 105 meter, coordinate can be written as 0, 1, 0, 5. And your coordinate of your hospital, it is at 90 meter distance, so it can be written as 90, 0. Coordinate is going to be 90, 0. X 90, Y 0. Here X 0, Y 105. Clear? And this tailor, suppose this coordinate is minus 90 plus 105. Here again you have to write minus 90 in this direction, minus 90. So this is your playground, and this is your tailor shop, and this is your hospital. The position vectors can be represent these 3 localities by using analytical diagram or in a coordinate plane. So your playground's coordinate, if it is P, then vector OP can be written as your X into I, X into I, that is 0 into I, 0 into I cap. And Y coordinate is here 105, so it is going to be 105 J cap. So this is the position vector, position vector of playground. And what is going to be the position vector of hospital? If it is OH, coordinate is H, so it is going to be minus 90 I, minus 90 I cap, plus 0 J cap, 0 into J cap. So hospital can be represented in this coordinate plane in this way. And what is going to be the position vector of your give and take tailor? Its coordinate is something like minus 90 plus 105. Suppose I am taking an example, it is not the exact figure. Suppose the coordinate is minus 90 plus 105. So if it is a tailor shop, if it is a T, so vector OT can be represented. I am taking an example. Its coordinate is minus 90 and 105. So minus 90 into I plus 105 into J, I cap and J cap. So if any position of any coordinate of any position is known, suppose a coordinate of this point is AB, and this point is suppose X, then the vector OX is going to be, this point has coordinate AB, and coordinate AB in first quadrant. So vector OX is going to be, vector OX can be written as, vector OX is AI plus BJ, AI cap BJ cap, AI cap BJ cap. This way we represent positions of any locality in a graph paper.